Alright, so now, some of you guys have a bad habit of not drawing lines through your dots. Okay? So this graph, a graph, is a picture of a relationship. Those dots are there to show the pattern of this relationship. Right? So, for example, this poster, you have cost of posters. So you have a number of posters here, and this is cost of posters. So you have a couple of data points here. Oh, this is how much one poster costs. This is how much 3 poster costs. This is how much 4 posters cost. But you can buy any amount of posters. And you don't want to draw the dots for every single one. We draw a line. The line represents every single combination you could have. Right? So we draw a line through here, and you go, okay, that represents every single combination we can have. So I'll grab my ruler here, we connect the dots, go for drawing here, and let's go for purple this time. So a line through the dots. This one happens to go through 0. Oh, there's my pen. Oops. And let's go here. And it goes like that. Right? So there is our line. Okay, so now we can use this line to answer questions. Right? So our first question, Riker, is everything okay? Right? Our first question goes, what would the cost of 2 posters be? We got Timothy saying 10. You guys agree with Timmy? Is it 10?
No.
11.
You got 16. I got 11.
I thought it was. I thought I saw like 2.
I'm hearing lots of different numbers.
Oh my goodness,
So,
what's going on today?
and lots of people kind of give me confused looks. Here is 2 posters, and we want to find the cost. So we need to go up to the line. So we go up to the line, and you go like this. Okay, we go up to this line. And we need to know what the value is. So we go from here, we go over this way. And you go, what number is it at?
16.
Right? And unfortunately, it does not fall perfectly at a line. So we have to do some guessing. So the first thing we need to figure out is, hey, what's our spacing? Each box, how much is it going up by? 5. Each box is going up by 5. So this is 5. This is 15. So we're looking at this, and you go, huh. So this price of 2 posters is more than 15, less than 20, right? And like halfway through the box would be like $17.15. So I heard the number people saying 16. That's a good enough guess. But if you said $16.50, you said $17, I'd give you the mark. This graph is not good enough to tell the exact value, but you can give me a pretty good estimate based off this. But if you said $11 doesn't work. $11 is nowhere near. $11 would be a line somewhere over here, right? So let's go with the $16. That's somebody's rough guess, right? And that's fine. So now it goes, the second part of the question is, if you had $24, how many posters could you buy?
4.
And you're going for 4. How do you come up with 4?
Because 4 is right under.
Yeah, because 4 is right under
Yeah.
Right under what?
the line for 24.
No, 3.
3.
3 is.
Yeah.
3. So
3.
we need to find where 24 is, right? So we need to find 24 over here. Right now, we have 20 here, 25 is here, all right? So 24, a little bit less than 25, right? So all this information is hidden. So we go from 24, we go out this way. Yeah, it's probably something like that. So we go down here, you can get here. So that'd be 3 posters, right? So there's 2 kinds of questions I can ask you with reading the graph. One could be, hey, I tell you how many posters are. So I give you a question based off the x-axis, and then you have to find the matching value over here. Or the other way around. I can ask you, I give you a number off of here. Oh, the cost is $30, or the cost is $15. How many things could you buy? And then you have to go the other way, right? But each time, you're starting with the number I give you, you go to the line, and you read the value off the other axis. All right? And that's all you do. So you need to have that line there. So now, the next part of this question is something that gets asked to you in grade 8, grade 9, and grade 10. So this line here represents all of the combinations that you could buy posters and figure out how much money it is. Right? So I go from here and read the value for 4 posters. I can go up here and read the value of 5 posters. So the question is, can I just pick any spot to go up and read values? So that line is saying that every single one of these spots exists. Right? For any dollar amount, there's a certain amount of posters I can buy. Right? So this one's kind of tricky one for grade 8 and grade 9 and grade 10 to always comprehend. Does every single value on that line exist? What do you think? Right? I see people nodding yes, and Timmy saying no, right? So more people saying yes, Timmy's nodding no. Why are you the odd man out here, Timmy? Why is it no?
There's like 1, 2, 3, 4, 8. They're not labeled. Keep down.
No, but you can have one poster. Just because it's not labeled, it's a number line. The number 1 is there, number 2 is there, number 3 is there, number 4 is there.
With the bottom row?
Oh, any of them, all right? All right. So Timmy is right with his decision, but wrong with his reason. Right? So every single spot on this line doesn't exist. Right? Now, here's the real life thing, right? The situation here is that, hey, these are all the different versions of money. You can go like this. For, let's say $12.50. How many posters can you buy? You go like this way, go to the line, you go down, it says 1.5. Can you buy 1.5 posters? No.
Buy 1.
You can only buy a whole number of posters. So when you look at these things, sometimes that graph is not valid for every single point. Because in real life, you can't always buy partial things. You can't buy a part of a poster, right? Or you're counting people. Only what's the cost for this many people to go? And you can't say 33.5 people are going. So that's the one thing you have to watch out for, right? Is like, can the partials exist? No. Because you cannot buy a partial poster, i.e. 1.5 posters. You just can't do that. You can't do that. Okay? So, I'm going to ask you to read values off the graph, just like we did before. That's not too bad. Just make sure you're on the right axis. You go to the line. Sometimes you have to guess at where the number is. As long as you're somewhat close to where the number should be, you're good. All right? All right, I'm not going to be too picky, as long as you can see how the number lines work. All right, the second part is, can you describe a graph? Okay, so I have this picture here of a graph, and you need to be able to describe it to somebody without them seeing it. Okay, so there's 3 parts to describe it. So I'll tell you what these 3 parts are on the quizzes and the tests and stuff like that. So the 3 parts are, the first sentence is you talk about what is the graph about. So that's your title for the graph, or your axes, right? Because that's what describes a graph. What's going on here? Oh, how many posters, how much money does it cost to buy posters? Right? So the first sentence is, what is the graph about? And that's your title, right? Or the title of the graph, if there's a title of the graph. Cost of posters, right? So your first sentence, you go, when you're trying to describe this to somebody, right? This graph shows the cost of posters. So just talking about the two different axes. That's all it is. So people can't see it, you have to mention it. So second sentence, all right? A key thing you need to tell to people in the graph, about the graph, is where does the graph start? So that's your bottom left-hand point. So it starts right here, right? So you say the graph starts at one poster costs, what are we going to guess here? What number? 8, I think I heard, right? So that's not a bad number, right? So the second sentence, the graph starts at one poster costs $8. Okay, so you told the people what are the two things you're talking about in this graph. You've told people where the graph starts. The next part is you gotta describe the steepness of that graph. All right, and that is how do the values change. Okay, so you go from what you're going to do here is you are going to pick 2 points on the graph and you're going to draw yourself a little triangle, right? So I'm going to pick these 2 points. Doesn't matter which ones. You're going to pick ones that are easy to use. So let's go from here to here and from here to here. All right? You can make yourself a little triangle, right? And you're going to figure out how long each of these lines are, right? So the bottom line of this triangle, it doesn't matter. You pick any 2 spots on the line, right? So the first one starts at 1, right? Oops, let's go here. Come on. Starts at 1 and goes to 3, so that's a distance of 2, right? So I'm going to put the number 2 here, right? The other one starts, let's go purple, starts here, which we said at 8, and it goes all the way up to, I think we said 24, right? So it goes all the way up to here, which we said it was 24. So how far is this distance? What's the distance between 8 and 24?
16.
16. Or you go 24 minus 8 is 16. Okay? So these are the 2 numbers you're going to use in our next sentence. So or it goes like this. You start talk about this one first. You go, every 2 posters will cost you $16. Right? So that describes to the person how the graph is changing. Right? So, and that pattern stays the same. If you draw the triangle anywhere else, it's always going to be that pattern. For every 2 posters, the cost goes up by $16. Right? So last sentence. Right? For every 2 posters, the cost goes up by $16. And that's it, right? So you described what the graph is talking about, cost of posters. You said where it starts and how the values are changing. So those are 3 things you need to be able to do. The last one's the trickiest one, but you just have to just draw a little triangle. And we'll do more practice of that next day. So we'll stop right there.